We want to look now at how we can find the solution to this system of linear equations in two variables through an algebraic approach. We talked a little bit about how we might do it graphically, but that would present some problems if the solution point was not a point consisting of whole numbers. It might be very difficult to read the partial numbers to get the solution. So we want a method that will work algebraically that will give us those exact solutions even if they're not whole numbers. The method that we're going to look at in this series of videos is what is called the addition, or sometimes called the elimination method. What it relies upon is the fact that if we have equations, we can add them together. Because in effect, if I wanted to add -7 to both sides of this equation, I actually could add those two terms in place of -7 to one side of the equation, because this equation tells me that the sum of these two terms is equal to -7. So if I wanted to add -7 to the right side of the equation, 14 plus -7 would give me 7. Instead of adding -7 to this side of the equation, instead I could add 2x plus 3y, because these two terms are equal to -7. And in effect, I would be adding the same thing to both sides of this equation. Here I added it as -7, the single term. Here I added that quantity as 2x plus 3y, because these terms added together are equal to -7 according to this equation. Now watch what happens when I do that. When I add these terms together that are here on the left side of these two equations, 5x plus 2x gives me 7x, and minus 3y plus 3y, that gives me 0. These terms are additive opposites. -3, +3 are additive opposites. Those terms added up to 0, and look what it created for me. A linear equation in one variable, which I can solve by dividing both sides by 7. So x equals 1. And I have found the x value of the ordered pair that is a solution for both equations. That is the solution for this system. And now if I want to find what the y value has to be, I simply take this value of x being 1 and put it into one of the original equations. For instance, let's put it into the top equation. Let's let x be 1 in the top equation. Now I've created another linear equation in one variable. The variable is y, and I can solve that equation to find y. I'll subtract 5 from both sides, divide both sides by -3, and I've now found the y value of the ordered pair that solves both equations. This ordered pair, 1, -3, is the solution to this system of equations. If we plug 1 in for x and -3 into y for this equation, it makes the left side 14. If I plug in 1 for x, -3 for y, it makes that side of the equation -7. This is the one point, the one solution that those two equations have in common. Graphically, it would be the point where those two lines intersect. And this technique, known as the addition or elimination method, is one of the methods algebraically we can use to find that solution of this system of linear equations.